complex coefficients of polynomial. These are polynomials when the coefficients here are an imaginary number. Now, this particular one is actually quite a simple one to do, but if you're trying to use substitution techniques, you'll be in a lot of trouble. So what we do with this one is we first have a good look at doing this by pairs, something you did way back in perhaps year 10, right? So to factorize this, we'll split this one down the middle and we'll get x squared outside of x plus I, and take the common factor of minus 2 here, and we'll get minus 2 outside of x plus I. That's simple. So now we take out x plus I as a common factor, and we've got x squared minus 2. So therefore we have x equals minus I, or x squared minus 2 equals 0, which obviously becomes x squared equals 2. So x equals plus or minus root 2. I'm sorry, I put x's in there. It should be in z. It should have been, oh no, this should be an x here at the start. So whether you call it x's or z's, it doesn't really matter. So these are the zeros, minus I, plus or minus root 2 are the zeros of that polynomial. Done. In this next example, we have to find the solutions to this quadratic. And notice we've got complex coefficients here and a complex number at the end. Now to do that, we're just going to use the quadratic formula. So as you know, A will be equal to 1. Your B is equal to 2 minus I, and the C was equal to minus 2I. Putting this in the quadratic formula, we get that Z is equal to minus this. Now I might just swap those around. That's I minus 2 plus or minus the square root of this one, 2 minus I all squared, minus 4 times 1 times minus 2I, all over 2 times 1, or just 2. Now being very careful with all these negatives hanging about, we get plus or minus the square root of, this becomes 4 minus 4I, and we square that, we're going to get minus 1, sorry, plus 1, isn't it? I beg your pardon, minus 1. Okay, and this one is plus 8I. You just take a lot of time getting this part right. Easy to make a mistake. All over 2. And that gives me I minus 2 plus or minus the square root of. Now this becomes 3 plus 4I all over 2. Now we're not out of the woods yet, because we've got to find out what this 3 plus 4I is, the square root of that. So what we'll do now is we'll let z squared equal 3 plus 4I. Now z, you know, as a complex number is x plus iy, so it's x plus iy all squared equals 3 plus 4I. This becomes x squared minus y squared plus 2xyi equals 3 plus 4I. Now, equating the real and imaginary parts, we get x squared minus y squared equals 3. And here I get 2xy equals 4, or xy equals 2. Now that's a fairly complicated thing to solve, but we can use a bit of trial and error methods and we quickly see that x would be equal to 2, and y was equal to 1, or x was equal to minus 2, and y equals minus 1. We'll just take this one, because we don't need to do this one, because we've got the plus and the minus thing here. So we'll write here that our z is equal to I minus 2 plus or minus, now this will be this, the square root of that one obviously is equal to minus, here it is, back up here somewhere, minus 2, or 2, plus I, through 2 plus I, all over 2, and that gives me, taking the positive one first, I minus 2 plus I, all over 2, and the other one is I minus 2 minus 2 minus I, all over 2, and that gives me, these 2's cancel out, 2I becomes I, and this one, the i's cancel out, I get minus 4 over 2, or minus 2 is the other root. Done.